Question 11. We have a point E has coordinates. Those ones, a line through. Let me first highlight this down. E has these coordinates. We have a line which passes through E and parallel to this line meets the plane at a point B. Then a perpendicular line from E meets the plane at C. Find the coordinates of B and C. So we have point E with these coordinates. Then we have a line. We have a line which passes through E, and it is parallel to this line. It's parallel to this line. So we have a line. We have a line which passes through E. It passes through E, so we shall get this position vector from E, and then we shall get this directional vector from this line. Since this line through E is parallel to x over negative 2 equals y equals z plus 1 over 2. So they have the same directional vectors. So we shall have our D as the directional vector from this line is negative 2, 1, negative 2, 1, and 2. These denominators form that directional vector. So we have now our required line as 2, it passes through E, 2, 0, negative 1, n plus t, negative 2, 1. Passes through this point and parallel to this line. They have the same directional vector. So this line meets the plane x plus 2y minus 2z equals 8 at B. So I'm going to let R be x, y, z. So substituting back, we shall have x, y, z. This is equal to 2, 0, negative 1, n plus t, negative 2, 1, 2. So we shall have x as 2 minus 2t, then y as t, then z as negative 1 plus 2t. So we have these points. We are going to substitute them in the equation of the plane, and we get the value of t. Our equation of the plane is x plus 2y. Since they meet, so you just substitute in this equation. So we shall have 2 minus 2t, then plus 2t minus 2, negative 1 plus 2t equals 8. So you try to simplify that. You take note of this question. So what do we have now? We can simplify. We shall have 2 minus 2t, then plus 2t, plus 2 plus 2 plus 2, then plus 2 minus 40 is equal to 8. So this and this, they will go out. This and this, that is 4 minus 40 is equal to 8, implying that negative 40 is equal to 8 minus 4 is equal to 4 is equal to 4. 8 minus 4 is 4. So over negative 4 over negative 4. So we have our t as negative 1. Our t as negative 1. So we can substitute back. We shall get x as 2 minus 2t, which is now 2 minus 2 negative 1. And this is equal to 4. This is equal to 4. It is equal to 4. Then y is t. So y is t, which is negative 1. Then z is negative 1 plus 2t. Negative 1 plus 2t, which is negative 1 plus 2 negative 1. This is equal to negative 3. Negative 3. So we have coordinates for point B as 4, negative 1. For x is 4, y is negative 1, then z is negative 3. Then part B, what do we have? They want the coordinates for point C. For point C, so if we continue with that question, they are saying that a perpendicular line from E meets the plane at C. A perpendicular line from E meets the plane at C. So we need to get this equation for that perpendicular line. It is from E. That means that it passes through E, and our plane is x plus 2y minus 2z is equal to 8. So perpendicular line from E. So we have this situation. Point is somewhere around there. Then we have a perpendicular line from this E. This is the perpendicular line. It meets the plane. This is my plane. Meets the plane at point C. So we need to get the equation of this perpendicular line. So since that line is perpendicular to the plane, then the directional vector of this line, since this line is perpendicular to the plane, the directional vector of this line is going to come from the plane. In fact, the directional vector of that line is the normal vector from the plane, and that vector is we can write this as x, y, z, then dot. The coefficient of x is 1, the coefficient of y is 2, coefficient of z is negative 2, equals 8. So this is the normal vector of the plane, and that is the directional vector of the line. So what do we have now? So we have that line which passes through E. So the coordinates for E, we have 2, 0, negative 1, then plus t 1, 2, negative 2. Now this is the line which meets the plane, So this line meets the plane at C. Meets the plane at point C. So we want coordinates for point C. We are going to do the same stuff. We are going to let R have these coordinates. Then substitute back, we shall have X. This implies that we shall have X, Y, Z as what? XYZ. XYZ is equal to 2, 0, -1, then plus T, 1, 2, -2. So we have our X as 2 plus T, comma, our Y as 2T, our Y as 2T, then Z as -1 minus 2T. I'm just adding this side. Then the plane, we are going to substitute this. Since this line meets the plane, we just substitute. So we shall have 2 plus T, then plus 2 times 2T minus 2 times -1 minus 2T equals 8. So we shall have 2 plus T plus 4T, then plus 2, then plus 4T is equal to 8. So you collect like terms. This is 5, then plus 4, that is 90. Then you have this and this, which is 4, I think. So which is 4. So plus 4 equals 8, implying that 90 is equal to 4 over 9 over 9. So it implies that T is 4 divided by 9. That is T, 4 divided by 9. Now we can substitute back. Here. So we shall have our X, which is 2 plus T plus 2 plus 4 over 9. 2 plus 4 over 9, that is, I think it's 22 over 9. Then Y is 2T, which is 2 times 4 over 9. This is 8 over 9. Then we have Z as -1 minus 2T. And this is -1 minus 2 times 4 over 9, which is -9 minus 8. I think it's -17 over 9. So we have coordinates for point C as 22 over 9, then 8 over 9, then -17